material inventories for responsive design in fashion practice. And we have several of the authors here, so I'm not sure who's presenting, so or whether you're doing a sort of group presentation. So do you just want to start and introduce yourselves? Thanks.
Hi, Ben. Thank you for the introduction, and thanks, Tim, for that great keynote. Thank you, conference organisers. My name is Ricarda Bigolin. I'm from RMIT. I'm presenting today with Stefanie, Malmgrende, Oliveira, and Erika Blomgren and Anna Lidström from the Swedish School of Textiles. Just as a flag, we might be over-ambitious with trying to share our presentation together, so we'll see how we go. And also we might have missed the memo about the 10 minutes, so we planned for 15, but I will be very conscious and I'll move through extremely fast like lightning to make sure we don't go over time. So I'll begin. The other part of this project is Clemens Thornquist, also from the Swedish School of Textiles, who's not virtually here with us today. Next slide, please.
Sorry, no.
Great. We're also sharing slide responsibilities just in case there are any issues. Also, thank you for the committee moving this presentation into this section. It's not quite on the engineering side of things, but it is about upcycling practices in terms of education as well. This part, just first with acknowledgements, this research is part of a funded engineering grant from Vinnova based on circular economy that we're part of and that this project was part of. It was about determining the design methods needed for reuse and upcycling of waste materials and how that this can really impact responsive design approaches for fashion. And we were very keen to overcome institutional barriers that limit this potential, which I will go on in a moment. Next slide, please. We determined that part of the challenges in this conversation on upcycling is actually the conditions within education programs. We determined that around things like curriculum design, which is the content that's in courses, pedagogy in terms of how learning happens and how this might conflict with notions of upcycling. We believe that a broad and variety of design methods are needed that are not just about repurposing of materials, that are actually tools to engage differently with very different conditions of materials. Through the basic way that we've approached this research, it is creative practice. So the research team conducted creative practice experiments, which were then applied and tested in curriculum design, in assessment frameworks, learning activities and experiences across BA and MA fashion design programs in Melbourne, RMIT University, and the Swedish School of Textiles, University of Borås. The other factor that we really determined was that often in foundational learning in fashion design programs that involves technical skills and competencies, learning how to construct, it inherently conflicts with upcycling. So students often learn through the use of raw materials. So these are some of the things that we need to address, and which brings forward this notion of garments as materials. So this is part of a learning tool. So instead of only within this particular study showing the methods that can be used to reuse materials, it's also really showing how they can actually be used for learning tools and also course design. We also attribute that the industry expectations of graduate outcomes and abilities of fashion design students and graduates needs to be changed, which is something that we'll talk about in terms of future ideas and scopes of the project. Next slide, please. To start the research, we looked at practice methods. So we were very interested in identifying, similar to some of the ideas mentioned by Tim, where examples where there's different approaches to the use of found objects and materials, which is very common in fine art and contemporary art practice, and the notion of the ready-made. And also how these materials are repurposed in sculptures that communicate consumption politics, values, memories, and material cultures. Also the way that they're formed in assemblages, sculptures, and spatial arrangements that show a reforming and a rearrangement of relationships with materials, as per the example here shown of tenet of culture. The other thing that we observed was a lot of artists and contemporary practitioners are using this notion of the audit, which is something that scholars such as Fletcher talk about in terms of wardrobe studies, the notion of auditing personal possessions to sort and understand different materials. The collecting and categorizing and grouping of these material conditions is also something we found as well in surveying these methods. And also the really importance of photographic documentation when using upcycling practices, and the notion of how this photographic imaging becomes a form of prototyping if we're not always using raw materials as part of, you know, the learning in fashion design. Next slide, please. These fashion and social studies methods really came in to kind of collate and analyse the research findings, of which were predominantly practice experiments from the team and in the curriculum. As mentioned before, I think wardrobe studies and methods by Fletcher and Klepper is an important thing to kind of acknowledge here, which really is an established way of understanding interrogations of personally acquired or pre-owned garments. And similarly with understanding that and the wardrobe kind of studies aspect, it's also the object-based research around that we found quite interesting. Apajurai and Kopyatov in terms of object biographies and biographies of the thing, which really interrogate an understanding of the origins of things and and speculating on uses and life cycles. Next slide, please. And that's over to you, Stefanie and Erika.
Hello, I'm Stefanie. And here we have the overview of design methods that we have been working with: material inventories, sourcing, cataloging, and comparing material conditions, understanding the conditions of post-consumer waste textiles and their origins as second-hand or dead stock materials, garment biographies, annotating and understanding material conditions and origins, design methods for garments as materials, removing or changing forms such as cutting materials, sculptures and assemblages to build new forms and garment functions such as folding, layering, stuffing, and rolling of garments, arranging garments and materials in a square frame, create swatches and scans of materials and poetic captioning. Next slide, please. And we started out with a method development, we called it material inventories, where we sourced materials from local second-hand stores and companies that had overstock materials, and we categorized the items. Here you can see in the first row a selection of t-shirts that we carefully documented and looked upon. They are varying in regards to form and material. And in the second row, you can see how we have started to relate the materials to each other. So this is the first step, a sorting and selection process that you can see. Next slide, please.
Yes, and hi, Anna here speaking. This watches and captions are a part of my licentiate thesis on remake, and this is a method developed that opens up for an alternative view to view beyond the sort of the routine-sighted way of looking at garments as materials, to look beyond the preconceived notions of garments, because garments often tend to stand in front of the actual material. You see the t-shirt but not the material somehow, and this is then a tool in order to forget and detect material instead. So this is just an example of that.
Yes, and here we have some examples within the material inventories and the materials that we have been sourcing. We really started to play around with them, and here you can see different examples here for layering and stuffing. On the next slide you can see layering and cutting, and that goes on over the next 4 slides. So Anna, you can just flip through them. So we were playing around with these materials, looking how can we relate them to each other, how can we look upon these items that are designed in a certain form and have certain material and form characteristics, how can we look upon them from a raw material perspective again? And here's an example for layering and rolling. And the next slide, please. And from this method development, we did a method application. We constructed 4 workshop stations that we were exploring with our bachelor and master students, and we invited a Swedish company to come in to give us feedback. And Anna, if you could go back to the square, please. Thank you, to the first. Yes, here's a workshop station called the square. So a square was taped on the ground, and the students were supposed to drape materials into the square, and they could come up with different compositions of materials. And the aim with that was to really achieve that they can look upon the materials in a different way and erase some of the features that are so characteristic for these materials. So sometimes they might have kept certain details, and in other materials they might have drape them in a way so that it gets a raw material aesthetic. Next slide, please. Relate and Create was a workshop station where the students could select 2 or several garments that they would then relate to each other. And here's, for example, an example of an 80s dress. So if that is related to a t-shirt, what kind of combinations could one come up with? How could one push this expression into something new and modern? And on the next slide, you can see some examples where 2 students have collaborated and worked with coats, jackets, t-shirts, turtlenecks, and in relation to print in a digital way, and they have come up with several new relations between these garments. This workshop station is called Garments Wear Garments, and the garments are dressed upon each other in order to come to new forms, new expressions, new relations. Sometimes the hierarchy of garments might be changed. That's also visible in the next slide, Anna.
Sorry.
Thank you. Here we can see what the students have done with it, and they switched the hierarchies of garment upside down. And the next slide, please. Crop the Line is the last workshop station where so different line systems were drawn on the ground, and the garments were cropped along those lines. Lines are a very important feature within garment construction. So to come up with radical new line systems that where items are cropped along can offer new possibilities. And here are some examples where students have been working. Next slide. And I'm handing over to Ricarda.
Thank you, Stefanie. Thank you, Erika. So I hope that this gives a sense of some of the other examples that we have not included within this is also how these methods are applied in course design, in assessment design. But the emphasis is that in order to really understand the scope of this, like mixed methods are needed. So we do kind of need to, in terms of determining barriers in the uptake and upcycling, we found that the focus on using creative practice experiments and looping back into teaching and course design was a really helpful way of understanding that. And I think it really emphasizes that these materials become the way that design is taught, and, you know, alternatives to pencil and paper and drawing. It's a really different kind of method where they've become the foundation for learning design, for learning basic compositions, for learning scale, all sorts of things like that. And the importance is that it does need to be embedded throughout education programs. It can't just be something that's kind of tacked on. If we do want to produce designers that are much more responsive, we actually need to reevaluate our whole approach to curriculum design. And that really hones in on the importance. It's not just the design methods, it's also the context of these post-consumer waste textiles, their origins, the sourcing, we haven't touched on the fact that the notion of second-hand itself is something in scholarship that people are really kind of playing with at the moment. When is it second-hand? What determines vintage and the differences between the actual materials used in the process, as well as then dealing with industry dead stock, which are often the categories that we see in this context. And finally, the notion of garment as materials, I think, is a very useful finding, to not think of designing fashion from materials into garments, but thinking of the use of these from raw materials. Also, the importance of images to document as part of the prototyping process in fashion, and the application of all of these across different types of curriculum and pedagogies. I think the way forward for us, and in this research, which we hope to continue, is collaborating differently with industry partners, and also understanding and unpacking disciplinary boundaries and industrial boundaries around this, and around the way that we are kind of thinking through how the upcycling processes, as well as the things that happen to the material. It's a complete rethinking of how we design and who we design for, and a real unpacking of that process. Final slide. And that is, that is the, I think that slide we can go and just go to the thank you. Oops, missed something. No worries. Thank you very much. Thank you. I hope that gave a rough snapshot. I'm sorry if we were slightly over time. I hope we sped up. We didn't speed up too much to lose the content, but I'm really grateful to be here. And thank you to Erika, Stefanie, and Anna as well. Thanks, guys.
Thank you.
Fantastic. Yeah. Thank you all very much. That was a fantastically choreographed presentation from 4 of you, fit into 15 minutes. That's very good. And what really stood out to me there was that while the practice and the examples you were showing were very, very fashion and textile based, actually what you were saying, I think, was equally applicable across different disciplines. You know, you talked about disciplinary boundaries, but you know, you could so easily have just replaced the word textile with product or with building. You know, so this idea of garment as material could be, you know, building as material, product as material.
Exactly.
But I think we probably need to learn a lot more from each other across disciplines. There's a risk of, you know, the textile people staying together.
Yeah, I think so. Thank you.
So no, I think that's very, very interesting. Now, we haven't got much time, but I'd love to have a couple of questions if people have got some quick questions, and if they want to try and use the hands up feature, or just call out. I mean, there aren't too many of us here. Does anyone have a quick question?
There's a question from Rules. If you check the chat box.
Yes, there was a comment. Seems like the hands-on approach is critical here. Not all designers work directly with the materials they make designs from, astoundingly. Can hands-on be virtually achieved? So this is from Ruth Morrow at Newcastle University.
Yeah, I mean, I think kind of the way of, like, I think the upcycling practices and approaches sit really closely with digital ways of working as well, and the imaging of what you do with materials, and the notion of how we analyze images, and how students analyze images of, you know, proportionally arrangements of materials, and how that influences design. So for some of the examples within this project also have applied to courses I'm currently teaching in Melbourne, Australia, where we're still in stage 4 lockdown, where we have no access to anything, where students and the limitations and the restrictions of these approaches are really viable in different ways, and put students on a kind of even playing ground. So yeah.
Thanks. I'm just having a quick look at the chat. Did the students across the institutions all to each other at all? Elaine, sorry, could you just maybe tell us what you're asking there?
Yeah, sorry. I just added, I realised there's a mistake there. Did the students across the institutions collaborate or talk to each other at all to see different cultural approaches or interests?
In this part of the research, no, but I've been collaborating, luckily, with the Swedish School of Textiles for many years. I go there quite regularly they often come to RMIT, and we have done a lot of cross workshops in that space, but the next phase is definitely looping up those students. And now that we're also used to virtual classrooms, that's definitely something that we can do. So yeah, so not yet, but yeah, I think what I was mentioning about the differences in the material context, like the materials came from the social non-profit sector of those kind of secondhand materials goods, but that context shifts when you get to Australia, and those sort of contexts of the materials that people have access to, I think, is a very important conversation in upcycling practices. What is available? Often they are discarded, often they are undesirable, often they're all a lot of polyester and fast fashion. So I think it's really important that is shared, I think, because of, you know, the global world that we're in. But yeah, that's a good point. Thank you.
Yeah, thanks. No, it's fascinating, of course, that discarded materials of little value in one context and location might be incredibly rare and valuable in other locations. So I think that global sharing is very interesting. Right, I'm afraid we do need to move on, but I would suggest everyone keeps an eye on the chat box if they can, because, you know, that way we can sort of keep the conversations going. So we've got Arlene Archer and Anders Björkvall presentation already lined up, so over to you.
All right, so what we are presenting today is actually a result of a collaborative research project that has been going on for quite a few years now, funded by the Swedish Foundation for International Cooperation in Research and Higher Education and the National Research Foundation in South Africa. All right, so the stuff we're doing is actually framed by a theory, so to speak, social semiotics. And social semiotics is it's sort of an integrated theory of multimodal meaning making. So we are interested in upcycling as meaning making. The multimodal stuff here has to do with social semiotics is directed toward language, but also image, color, artifacts, architecture, and so on. Very ambitious, but anyhow. And it focuses on the relationship between texts, and in this case, that would be translated into artifacts then, of course, social context and social practices. And the key concept here also for our presentation is that of the semiotic resource. Semiotic resources are resources that we as human beings use when we make meaning, and that could be grammar, letters, but also sounds, shapes, colors, words, and so on. And the questions we're addressing today can be summed up as this. What can social semiotics offer for understanding of upcycling as global and local meaning making? And how are semiotic resources used and recontextualized in upcycle objects? And how do they refract instances and fragments of discourses? So I'll say a few words about the sort of theoretical concepts that we work with, and then Arlene will come in and show you some examples. The data is basically South African made artifacts, although we have documented them also in Sweden, but they're all made in South Africa. And what we're focusing on today is actually artifacts made from waste plastic bottles. And it could be this type of jewelry-like artifacts. This is from a shopping center in central Cape Town. It's fish and birds made from washing liquid bottles, sort of a part of a commercial presentation actually in this mall. But also this type of upcycling that you all recognize, of course, light fittings and lamps and so on, made from bottles of different types. So we're interested in discourses, and we make a distinction here. We talk about discourses in, and those are discourses suggested by the materials themselves, so to speak, and in the actual design of the artifact. And these discourses in could be instantiated through explicit semiotic resources like types of materials, shape of the materials, color, and so on. And in this way, we are able to identify ideas and meaning potentials, that's what we call it, such as nostalgia, durability, environmentally conscious, and so on. but we also work with discourses around the upcycled artifacts that we're interested in. And these are located in practices and texts that are historically, geographically, or culturally related to the object. Sort of contextual view of discourses. And we use the concept of provenance here. We use it because it refers in our analysis to the historical or contemporary origins of any given feature of an artifact. For example, a type of design in another type of genre, another discourse, or practices of specific social groups or professionals. So provenance is concerned with the connotational meanings that actually build on specific types of cultural or social knowledge in order to be recognized when you look and touch and interact with an artifact. All right, Arlene, I'll leave it over to you then to go with the fragments.
Right, thanks, Anders. Right, so what we thought is that you can't presuppose the existence of a discourse. In that case, you sort of reify or take for granted that a discourse is out there somehow in the world. So in order to avoid that kind of circular or deterministic kind of analysis, we began to think about fragments of discourse. And in that way, we can think of the artifact as having in quite a range of discourses.
Arlene, I think you're breaking up.
Can we have the next slide, Anders?
Sure.
Yeah, Arlene, I think we missed some of that. Do you want to try and carry on and see if we can hear you now?
Yeah.
Yeah, I think we've got a connection problem for Arlene. I mean, Anders, I don't know if you can take over.
Sure, I'll try to take over. Let me see here where we are. We are at the discourses. All right, we are at this slide. Discourses around then. Give you an example of that. As an example of discourses around, we can look at this artifact, which is actually found in a shop in Stockholm. It's a curtain and it's made from cut up plastic bottles, which are strung on twine to make a curtain to hang across the doorway. The curtain was displayed in the Stockholm shop and it was hanging against the wall. The plastic curtain communicates a certain authenticity of origin, but it's also an example of an artifact that needs a narrative to reach its full authenticity potential, and that's the type of discourse around that we're talking about. A narrative was provided by a salesperson in the shop, and we were documenting this artifact. It was claimed that the plastic bottles were collected by unemployed women as rubbish discarded on the beaches of Cape Town. The same women then produced the artifact, which moved from a local to a global market all the way to Europe, to Sweden. And the authenticating narrative that accompanies this artifact is built on environmental, ethical discourses of women's empowerment, poverty prevention, and social upliftment in Africa. But the authenticity of the artifact is somewhat undetermined by the limited wear and tear of the upcycled bottles that one might expect if they had been exposed to natural elements on the beach here. Arlene, are you back with us? Can we... Okay.
I'm sorry, I don't know what.
That's fine. You can take
All
over
right.
now.
Sorry about that. Okay, thanks, Anders. The affordances of giving a co-presentation, the one can take over from the other. So in looking at discourses in an artifact, in this particular one, we looked at shape, color, and size, and these are resources used for patterning in the curtain. So the shapes of the fragments of the bottle remain recognizable, so we're able to discern the highly mundane functions of the objects that are used in other contexts. For instance, the one in the center there is a toilet cleaner. We can recognize that. We can also recognize lift-up nozzles for cool drink bottles and so on. Can you go to the next slide, please? All right. So another set of discourses circulating around upcycled artifacts is that of global design, taking into consideration environmental concerns. Consumerism is packaged as trendy and ethical. So we think, we theorize around these, that they have a high degree of mobility from local to global, from South Africa to Sweden, for instance. This image shows milk bottles. It's actually at my university in Cape Town, which a South African artist, Heath Nash, refashioned into large light fittings. So the lights are used mostly in domestic spaces, but also institutional spaces. So here the color white is the main resource, and only the white plastic from the milk bottles is used. The artist Heath Nash talks about translucency as a resource, which is a bit different to color, because the resource is about how light is used. The light shines through the plastic, transforming the white into a warm yellow glow, interspersed with gray, less translucent patches. It adds texture and depth to the artifact. So here the materiality of the milk bottles, such as the emboss of the brands, the logos, the state stamp on the milk bottles, the expiry date, for instance, the varied textures and thickness of the different bottles, these primarily function as markers of authenticity, with provenance in very mundane household practices, let's say. All right, next slide. All right, so what does social semiotics help us to think about in this context of upcycling? It helps us think about discourses both in, so we thought of just three, in fact, of color, shape, and material in this particular study, just to narrow it down. And in thinking about discourses around, we looked at the notions of authenticity, how is authenticity established semiotically, but also mobility. So here we also use that concept of provenance that Anders spoke about to discuss how upcycled artifacts relate to other artifacts, texts, semiotic domains, and practices. So this approach helps us to identify diverse and multifaceted nature of meaning making through upcycling, and how we can draw on such varied phenomena as environmentalism, poverty reduction, functionalism, and so on. And the last slide. So what have we shown? We've illustrated how an analysis of fragments of discourses and semiotic resources in an artifact, as well as the discourses and narratives around the artifact, can provide insights regarding local authenticity. And what perhaps could we have done better or doing more of in the future? What we don't know, and what this social semiotic method does not help entirely with on its own, is to think what happens when actual buyers and users of the artifacts interact with these in different contexts. So here we think you need to combine social semiotics with more ethnographically oriented methods, for instance, interviewing people and documenting uses of objects in homes. So that's it. Sorry about the interruption.
Fantastic. Thank you. Thank you both very much. Do we have any questions? Either in the chat or hands up? Are there any? Oh, no, that's not a, I thought I saw hands, but it's applause. Too many symbols. If we don't have burning questions, we are running 10 minutes late, so I would like to just move on to the next one. And if people come up with questions as we go along, we can always pick those up in the breaks. So I'd love to move straight on to Ashwathy Satheesan, whose screen is appearing now. Thank you very much.
Hello?
Is that, it looks a bit strange, it looks zoomed in at the moment.
Oh yeah, just a minute.
If you can just, yeah, perfect. That looks good. Okay, thank you very much. Over to you, Ashwathy.
Hi
Hello everyone. I am Ashwathy. I'm a product designer and researcher from India, and I'm going to present my graduation project carried out for IFB home appliances in the context of washing machine packaging in India. This project was an investigation into the field of packaging in mass manufacturing industry and an attempt to rethink its life cycle with an ecologically responsible approach. Every year, more than 3 lakh front-load washing machines are manufactured and packed at IFB's manufacturing facility at Goa to send to various parts of India. About 1/4 of this volume of the transported freight is just packaging. After its dutiful journey from manufacturer to the customer, this packaging ends up at the customer's house, from where it retires from its use to landfill. This results in around 24,595 meter cube volume of packaging waste generated every year, which can be visualized as space taken by 95,000 front-load washing machines. And if each unit in this GIF is a washing machine, then this number looks like this. So these facts state only the impact of packaging of IFB's front-load washing machine every year. Now, one can imagine the horrifying impact of packaging of all appliance industries. This project lies at the intersection of diverse yet connected topics like sustainability, packaging, and people. Packaging can be considered as a product whose journey aligns with the life of the product it's protecting, moving through various areas from manufacturing to retail to customers to waste management and more. So understanding this entire system was crucial for this project because of its scale and impact. Systemic design is a powerful tool to uncover such complex networks to find opportunities for improvement. The design process used for this project was exploratory and finding driven. It consisted of 3 phases, namely research and analysis, synthesis, and ideation. I would like to run you through some highlights of the project. During research, meeting people involved in the system from manufacturing to the end of life helped to get a macro and micro view of things. Observing and talking to them helped to collect the most relevant information and visualize them in the system. Above all, these conversations formed the crux of what shaped the project. Conversation during this research triggered a lot of ideas and inspiration. So sketchnoting and idea bank helped in capturing all these. Something that hit me was that there was a lot of energy left in the material that needs to be put back in the value chain. But the challenge was that 4 packaging parts fall in different categories in recycling value. In this, polystyrene cushion falls in the category of no value. So even after segregation, its value remains 0 because of lack of recycling system. After all this research, data was filtered through many stages of questioning and comprehension. Synthesis helps in ideas to resonate with findings. So use of design toolkits and method cards helped in this process. I'll briefly run you through these synthesis maps. This map shows the journey of packaging from its manufacture to the end of life. It also shows how the value of part fluctuates at different stages. Some insights that can be understood through this map is that segregating for recycling increases value from 0, and that reusing the parts gives more value than going to recycling. This map shows the stakeholders involved in the whole system of packaging and their positioning from primary to secondary and tertiary. Here, the manufacturer and the customer fall in the inner level, whereas the policymaker fall on the outer level. Voice of each of these stakeholders, from manufacturer to the rack pickers, were captured through empathy maps. It shows their feels, pains, gains. Through these, some engaging insights were captured. During ideation, as there were a lot of considerations and constraints to be taken care of, themes for ideations were made. These themes were based on synthesis data and idea bank. This helped in clustering and cross-fertilization. With this method, more than 160 variegated ideas were generated. Bundling these ideas helped in taking strong individual concepts to solutions of substance. This bundling was done on the criteria developed from directions identified before. So best parts of several ideas were put together to create 6 refined concepts. Here are the concepts. There were 6 trends that were observed in these concepts. One of the key insights found during synthesis phase was that reusing or upcycling of the package generated more value than recycling. Also, there were constraints of manufacturability and viability for business. Thus, upcycling at consumer level or mass repurposing presented as an effective direction that satisfied the solution criteria. So the new brief was to create an evocative prototype to change the mindset of people, create awareness, and to show the potential of packaging that is generally thrown away. It was also important for this concept to work with minimum changes to the existing infrastructure. For this, explorations were done on cardboard to get ideas about its potential and constraints. A lot of ideas were made. These mock-ups and prototypes help to sift out what works for the system. Getting back to stakeholders on the mock-up feedback helped in validating the concepts at an early stage. Now I'll just play a video of the final outcome. Now, why a stool? A furniture is something that is kept in front of the house and grabs a lot of attention. So a good stool can thus have a good impact on people. A seat is also linked to trust and feel. So a sturdy stool can thus drive positive feeling about reusing the material and helps in associating higher value to what is regarded as a waste. Moreover, the story of upcycling into a functional product adds to its value and shows care for the environment. As you saw, the patterns on the stool can be painted to customize it. There is also an online platform for sharing upcycle stories. Such experiences bring a sense of attachment, like emotional durability and pride to the stool. This increases its longevity and impact. This unfolding of different touch points adds layers to the experience of interacting with the product, making it more memorable and impactful. So reflecting on this project showcases systemic design as a powerful tool to navigate through wicked problems and to identify opportunities to improve the system. It's also a great method to validate upcycling as a solution and evaluates its impact at an early stage of the project. Moreover, it helps in identifying system service opportunities in the upcycling ecosystem, which can lead to new avenues to build holistic and future-proof solutions. Yeah, that's it. Thank you.
Thank you very much. Yep, fantastic presentation. Very nice example of design for upcycling. We're getting a few responses in the chat already. First of all, just some fun, enthusiastic, responsive, fantastic stool. Pointing out, of course, this is also a selling point for the company, as well as you know, so it should have economic benefits. And then a question, what about other materials? Were there other materials within the packaging, such as foams and plastics, or had they managed to eliminate those and just use the cardboard? And if there are other materials, could they also be upcycled?
So this was a 7-month project that I did. So one of the main problems that was like bothering me was the styrofoam. So, but because viability is a concern for businesses like this, the solution was divided into two parts, and one was immediate implementation, and second was material innovation to actually replace the polystyrene in the packaging. So the outcome that I showed you right now is the first phase of the project. And the second phase is actually like a long-term project that needs to be done on material innovation. Yeah,
thank you. And then also comments about the personalization of the stool by colouring it in, which it's a nice mix of having a very designed, specified upcycling, but then allowing some element of personalization. And what I was going to ask about that was there's obviously a sort of balance between creative upcycling, where you can make almost anything, and then this very sort of designed upcycling, where you have to make a stool. And I was wondering if you looked at anything in between the two, where you might be designing the packaging to help people make things creatively and make a range of different objects. Did that make sense as a question?
Yeah. So yeah, I actually agree with it, because mass repurposing in itself like poses a lot of challenges, because people have different abilities, and like you have to look at even the age group in which like this is made. And because the cardboard is also some amount of strength, you have to consider all those things before like doing something that's like for everyone to make. So like there are tiny things that like a brochure for tutorials, and a brochure comes with a tiny template in itself where people can make a small stool and try before making the actual 1:1 thing. Like the ideas like that were actually like made so that everyone understands it like easily, because of this like proper design thing, which makes it like accessible to more people, I feel. And like also to people who generally wouldn't go like do upcycling, it like encourages them to do it.
Yeah, definitely. I think that's one of the big things about this, is it might just introduce people to this idea of upcycling. And if they have this designed packaging one time, then next time they might get some packaging that isn't designed, but they, you know, think, what can we make from this? So it could just spark that the creative upcycling as well. Okay, thank you very much. I think it's time to move on. Thanks. So next we have Patrick Isherwood and Kyungeun Sung, upcycling of silicon solar cells. If you could, who's presenting? Great, there we go. Okay, thank you. Over to you, Patrick.
Yeah, hopefully this is I've managed to unmute successfully.
Yep.
Jolly good. Grand. So there's a bit of a change, I suppose, in a way. So I'm going to be giving a short presentation on the upcycling of, of silicon solar cells, and particularly looking at what the current options are, and hopefully give a bit of a brief overview of why it's important and why it's something that we need to look at. So just a little bit about me. I'm a lecturer in solar energy. It's the Centre for Renewable Energy Systems Technology at Loughborough University. And I mostly work in material, on the material side, but I'm interested in solar energy, particularly photovoltaics, so solar cells, right the way through from their construction, through their use and the end of life as well. So obviously this is more focused on the end of life than anything else. Okay, so quick introduction. I wasn't entirely sure what level to pitch this at. So if this is all things that people already know, then apologies, but hopefully it'll be a bit interesting and valuable to some as well. So first of all, what actually are solar cells? Well, they're devices which convert light into electricity, and they tend to be semiconductor based. So here's an example. This isn't actually a silicon cell. This is a particular device, a cadmium telluride device. This is a research one. This is something that we've made in our labs. As I say, they tend to be semiconductor devices, very much the same sort of thing as competing sort of technologies as well, in terms of how they function. So why do they matter? Well, they're a key renewable energy technology, and increasingly they're very important as a means of decarbonizing energy generation globally. So this is a graph taken from the BP Statistical Review of World Energy. And if you look at the global energy demand, it's very, very high. It's around about 1.6 times 10 to the 14 kilowatt hours per year, which is a huge amount of energy. And it's been increasing approximately linearly for quite a long time now. And that's the blue line on this graph. And that's on the left-hand axis. And on the right-hand axis, you have solar energy consumption. And as you can see, for a very long time, that was essentially zero, but certainly very, very low levels, until around about 2008 or 2009, when suddenly it really took off. And it's been growing almost exponentially since then. So it's a very, very big market. We're still not quite up to the level yet where we're able to generate everything that we need through solar. I suspect we'll never quite get to that stage. One of the things with renewable energy is we're always going to need a mix, but solar is definitely a key part of that mix. So why silicon? What's important about silicon? Well, it's the primary solar cell material. It's extracted from silicon dioxide, otherwise known as silica, the most common example of that being window glass. Silicon is used extensively in almost all semiconductor technologies. And in terms of solar cells, it's currently responsible for around about 90% of the market. It's grown as ingots, very, very large, usually single crystal, although it doesn't have to be. And these are cut into wafers, they're sawn into wafers. And in many ways, it is an ideal material, although there are specific problems, which a few of which I will go into a little bit more detail further on. So this is just an example of an ingot. This is a photograph taken at a conference a few years ago. And these are drawn from a molten silicon bath. I believe this is a single crystal of silicon. And this is what then gets sawn up into these individual wafers, which you can then use to produce the cells. So once that's done, once you've made your cells, they're then arranged into a module. By what that means is that the cells are arranged in strings, if you like. They're usually, or kind of columns, that kind of thing. They're usually known as strings, and they're usually connected in series, electrically connected in series. So a standard module construction consists of a cover glass, a glass plate, which is protective essentially because silicon is quite fragile. You then have an aluminium frame, which holds the whole thing together. Some sort of thick polymer backsheet material. In the middle, you have the silicon cells and their associated metal connections. And then the whole thing is held together by an EVA binder material, which is used to kind of laminate the whole thing together. So this diagram just gives you some idea of how that structure functions, how it's created. So when you get to their end of life, one of the interesting things with solar modules is that they have the industry standard is that they have a 25-year lifetime, and they usually come with a 25-year guarantee, which is quite unusual for manufactured products in general. And we're getting to the point now where there are some modules which are already reaching this age that have been around long enough that they're getting to that end of life point. However, the real is actually going to be in about 10 to 15 years. So if we go back to this graph again, the energy demand graph, I said before that the real uptake, the real spike in use of solar energy started in around about 2008 to 2010. So that means in sort of 10 to 15 years or so, we're going to have a huge increase in the number of modules reaching their end of life. What that means is that at this point, it's a really good time to be looking at how we deal with these modules at that point when they've reached their end of life, and how we recycle and reuse them, what we're going to do with them generally. It's not something I think that certainly most of the manufacturers are thinking about at this stage, but it will be very, very important in the not too far distant future. So some module components can already be readily reused or recycled, in particular the glass and aluminium. There are very well understood streams for dealing with that. But the cells themselves are rather more complicated. So in this presentation, I'm going to go through 3 existing routes, and then I'll quickly, if I've got time at the end, just mention something which is a very exciting possible new option as well. So the first one I'm going to talk about is the reuse, just straight reuse of old cells. This is arguably the simplest option in many ways. And it's possible because even after 25 years, the vast majority of intact cells still work perfectly well. On average, there's a typical efficiency drop of around about 0.7 to 0.8% annually, which is pretty minimal. That's not that big a drop in performance. What that means then obviously is that you can reuse these cells. You can take them out of the module. That involves desoldering them. Obviously you have to take the module apart first, desolder them to remove the electrical connections, arrange them in the new setup, solder them back together, and reform your new module. And you can do that whatever shape you want, or whatever pattern you particularly choose. And there's nothing fundamentally wrong with doing that. That's quite a good option. However, there are problems associated with this. The first one, and this actually applies to a number of the means for recycling silicon. Silicon is very brittle, so, and more so even than the glass. The glass itself is actually more flexible than the silicon. So extraction of intact cells can be quite hard work, and it's potentially very labor intensive. I'm not aware of anyone who's actually managed to automate this process. The problem here is that broken cells can't be directly reused. You may be able to reuse parts of them, but you have to cut off the broken sections. So just a quick video to kind of illustrate this. This was a demonstration that a colleague did in an undergraduate lecture a couple of years ago, just flexing a wafer. And you can see it just shatters straight away. They're very, very fragile. There are also potentially some issues with corrosion, not so much of the silicon, but to do with the overlying metal connections. And this is particularly an issue because it's a 25-year lifetime, but that's 25 years outside. It sat in some very harsh environments, potentially, particularly somewhere like the UK. It's very easy to get water ingress into your module, and you can have kind of point contacts, corrosion, all kinds of issues, which then have to be dealt with if you want to reuse the cell directly. So then the second process I'm going to describe, or that we looked at, is chemical etch processing. This is quite an interesting one in that it actually completely strips off all the surface treatments, all the additional films and the dopants within the material itself. What this does is it generates a completely fresh, high quality virgin wafer. So you're going back to the kind of starting point, if you like, before you generated the cell. These fresh wafers can then be used, they can be reprocessed to generate new high efficiency devices. And the major advantage there is that, of course, in the last 25 years, silicon processing and the efficiency, the techniques that we use to generate devices have improved quite considerably. So potentially what you're doing is you're going from a relatively low efficiency device to a much more high efficiency device, which will generate more electricity for the same area. This process can also be used on some defective devices and sometimes also on those which have been damaged during the manufacturing process. It does have some problems. In particular, it does require a use of a number of very unpleasant and environmentally hazardous chemicals. Again, you can't use broken cells. There are a lot of different types of silicon cell, different architectures and so on, and some of those will require different chemical mixtures to treat them. And finally, the process does remove wafer material. So the wafer that you get back is always going to be thinner than the original. just to quickly illustrate that. So this is a very basic architecture. This is a standard sort of design for a silicon cell, particularly a historical silicon cell. You have your back contact, which is usually aluminium. You then have your wafer. So the N-type silicon, P-type layer on the top, which is a doped part of the silicon wafer. They can be the other way around, but the ones I've seen are mostly that way around. You then have an anti-reflective coating, because silicon is a very reflective material, so you need to reduce that as much as possible. And that can either be a surface treatment, or it can be something which is coated on top of the silicon itself. And then you have silver bus bars, which are the electrical connectors as well. And obviously all of that then has to be removed if you want to get back to the bare silicon wafer. But doing that basically means you end up with this much thinner end product, or starting product, if you want to see it in that way. So then just quickly, the last process that we looked at was to use silicon as the used silicon as a feedstock to generate fresh silicon ingots. There are advantages here as well. So cells are already silicon. That means that there's a significant reduction in the energy requirements for ingot synthesis. And you can use all of it. You're not limited just to the working devices. You can use old cells, obviously. You can use broken wafers and fragments. You can also use the wafer cutting slurry, which is a significant source of waste. It's a significant waste stream in the silicon cell production process. And this produces fresh ingots, which, exactly as you would for a normal device, or normal cells, or virgin cells, if you like, can be cut into wafers and processed as usual. It is still an energy intensive process. And it results in the complete destruction of the old cells, which could be considered quite wasteful. The wafer cutting does produce significant waste, although, as I mentioned, that can also be returned into the feedstock. And the cell synthesis does use some very hazardous and environmentally damaging chemicals. In particular, things like this stuff. This is hydrofluoric acid, which is a particularly nasty material, and is one of the few chemicals I'm actually scared of. And gives you some, if you're not careful, gives you incredibly nasty chemical burns. And that's quite important, sadly, in the silicon cell manufacturing process, because it's one of the few things that actually etches silicon. So a few quick conclusions. The reuse of the old cells is definitely the simplest, but is not always appropriate depending on what you're trying to do. And it certainly doesn't improve the cells, it just uses them as they are. The chemical etching process produces virgin wafers, which can be used to make more efficient devices, but it's not necessarily straightforward. And both of these do require intact devices. And the use of old devices as a feedstock enables the use of broken cells and fragments as well, plus cutting slurry and so on, but it is still energy intensive, and it does involve some fairly significant chemical processing. And finally, just a very, very, very quick thing. Hope I've got enough time. One possible alternative which has been mooted very recently is electrowinning. Now, this previously hasn't been possible due to the use of aqueous electrolytes, but recently there's been some interest in the development of ionic liquids as alternative electrolytes. And the identification of a suitable ionic liquid could enable synthesis of solar grade silicon from old devices. It wouldn't require intact cells. You could potentially use broken fragments as well. But there's quite a lot of further research is needed really before that becomes a viable alternative. Okay, thank you very much for your attention.
Thank you very much. A couple of quick comments from me first. I thought, to start with, it's very interesting, this idea of anticipating waste streams. You know, very often I think a challenge in upcycling is that we're sort of always responding to waste as it's generated, or there's an uncertainty about what waste materials will be available in certain places at certain times. So it's very interesting at the beginning that you were anticipating that there will be this large waste stream coming online, you know, in 10 to 15 years. And that gives you the time to then work out what to do with that, whether it's reprocessing, whether it's creative upcycling. So I think looking at that, that could be done much more broadly, of sort of anticipating waste streams. But it also made me think, your presentation made me think about the importance of collaborating. You know, here we've got a lot of designers, but the importance of collaborating with experts in particular technologies or particular materials to really get this understanding of whether sort of creative upcycling or reuse or remanufacturing is actually the best option. So were there any questions? There are just some comments about people generally being concerned about end-of-life, people realizing that we've got these large numbers of solar cells with limited lifetime. Similar challenges in the wind industry, handling wind blades at the end of their life. I mean, a question that I had was about this 25-year lifetime, because you commented that actually they're still working fine. So I was wondering what sense the lifetime is 25 years. Is this something that's just been decided by the industry, and could that simply be extended?
Well, yes, it's a very good question. I think it's difficult to say for certain. One of the reasons I say that is because actually more modern, there has been quite a number of changes in the way the cells are made. So certainly that's absolutely true for older devices, the ones which are starting to come to their end of life now. But more modern ones, one of the major changes has actually been to make the whole thing a lot more efficient, so they can use much thinner wafers. I mean, they're down to around about 100 microns now, I think, for the wafers. But of course, that does also mean they're more fragile. So I think it'd be interesting to see, to be honest, but I wouldn't be surprised if a lot of them did actually end up lasting a lot longer than 25 years, certainly. And if that's the case, then yeah, I mean, there's no point, if it's still effective, if you're still getting good, useful electricity out of a particular module, then yeah, potentially there isn't really much point in stopping using them at that point. That said, people may. It depends a little bit on things like contracting in solar farms and things like that. So I don't know. It'll be interesting to see, I think. Yeah,
that was my concern of whether this is sort of planned obsolescence, that we have this 25-year life, 25-year guarantee, and everyone will just have this feeling that, oh, this has reached the end of its life, we need to change this, and there'll be pressure on people to renew things unnecessarily.
I suspect there's going to be an element of that, definitely.
Yeah. Just one last quick question on the chat about whether these can be stored safely while waiting to be repurposed, which I think is also a interesting general question of, you have some materials which you can sort of stockpile and then upcycle later, but others, degrade, are difficult to store. So how does that work in this case?
Yeah, I don't think storing them should be too much of a problem. There are possible issues. I have a colleague who's looking at the degradation through essentially light-based degradation of the EVA binder, and what effect that has on the cells themselves, if it has any effect. Basically, it releases acetic acid, I believe, as it breaks down. So, and does that have any sort of impact on the cell itself? So, I mean, I suppose in theory, something like that could be an issue, but at the same time, I mean, these things are supposed to be sat out in a field for 25 years under whatever conditions the weather throws at them. I think on that basis, storing them even for another couple of years, once they've been removed from the field, probably isn't going to make much difference.
Yep.
I mean, certainly we store them in crates in our lab before we test them and do that sort of thing, and they're always fine. So.
Actually, that just leads nicely into a final question about the playoff between durability and weather resistance and modularity and ease of disassembly, and whether you could comment on whether that's considered or whether it's just all about the durability and therefore that compromises ease of disassembly.
I think at the moment it's definitely the latter. I mean, one of the problems that I think anyone who works in engineering things that go outside will know is that it's impossible to seal anything perfectly, but you can try pretty hard. So that's very much where the industry is at the moment. They're very much focusing on manufacturing these things such that basically they do end up being quite hard to take apart because they're very robust. Hopefully that may change. I don't know. It depends a little bit on what they use, what they're prepared to use as the backsheet material in particular, I think. It is possible to disassemble a module, but it can be quite difficult. EVA is quite tough, or can be quite tough, certainly in large quantities. Yeah, but certainly at the moment, that's very much the focus is definitely on durability. And I think as it stands, they're not really looking so much at what happens at the end of life. That's still quite a new conversation, I think.
Yeah, no, a common problem. Okay, thank you very much. We need to move on to Neil Maycroft, who's talking about the role of design in upcycling research.
Okay, okay, bear with me. I've never used Zoom before, so we'll see what happens. Okay. Oh God.
You got the share screen at the bottom?
Yes, yes. It now wants my system preferences. So.
Yeah, sometimes they're
so
security things.
Okay. Right. Okay, let me see. Now then. You got it?
Yep, that's working.
Okay,
Fantastic.
thank you very much. Thanks, everybody. Okay, so scapegoat or saviour, the role of design in upcycling research. My intervention, I suppose, my interest in this is born of a conflict that comes out of two kind of strands of research and experience. One is that by training, I'm a social scientist with a history of research into waste, obsolescence, hoarding, ambiguous material culture, and so on and so forth. But the second source of my interest is that for the last 25 years, I've taught in schools of design, university schools of design. Increasingly teaching in the studio a range of kind of historical contextual considerations of design. And this gives me, I think, a kind of slightly different perspective on the upcycling debate when I consider how we teach students about design, what we teach them, what design actually does. And it certainly generates for me more questions than answers. So I'm not going to be provide very many answers that will resolve this conflict, I don't think. But certainly, I think if we look at the upcycling literature, we find two broad definitions of design. One is a kind of scientistic, positivistic one that comes out of, I think, an obsession with the notion that there's something called design thinking, which is a kind of repeatable, universal, problem-solving, scientific, logical process, and is very much attributed to the work of Herbert Simon, who wasn't a designer, but his definition of design from the 1960s seems to have caught on. And the counter tendency to that would be those people who see design as a very, very kind of situated, unique, creative practice, which isn't amenable to being talked about in that kind of positivistic language that we associate with more scientific discourses. Within the upcycling literature, we find the claim many times restated that design is responsible for things like waste, obsolescence, unnecessary and repeat consumption. And we find the other claim that design should result in non-wasteful products, and they're defined variously as reusable, recyclable, repairable, upcyclable. That design should somehow result in a new political economic system, a circular, sustainable economy, and people explicitly talk about the design of this economy as though somebody sat down and designed the one that we've got already, which they didn't. And the kind of underlying claim of that somehow is the design of obsolescence itself. It always struck me that design is doing some very, very heavy lifting in the literature on upcycling. And I kind of think that it's being asked to do too much. Firstly, we see a very abstract conception of design at work. Design becomes a synonym, I think, for a kind of general notion of purposeful action. I think that a lot of it's wishful thinking. I don't think design is neither the problem here nor the solution. I think it's the political economy, to paraphrase a well-known saying. And I also think there's a good deal of design determinism going on here. That design, if we only design this thing better or that thing better, or we can design this system then the problems associated with waste, overconsumption, over elaboration of products and so on and so forth can be addressed if only designers would get their act together. I would argue for a rather kind of straightforward definition of design, one that I think underpins how we teach designers in design schools, is that primarily they're form givers. They give forms to things. And secondly, they are meaning makers. I would probably kind of soften that a bit and say that they offer meaning rather than make meaning, because there's no compulsion for anybody to accept the meanings that are being offered by designers. But they're definitely form givers and meaning makers. And the most important thing to remember, I think, is that out there in the world of work, designers are working within material, financial, organizational, temporal, conceptual constraints. And we may sum that up as the brief. And the various constraints on what they're asked to do can sometimes be led by organizational concerns, they can be led by temporal ones, or any of those competing variables there. But I suppose in using the more social science type of language, what designers do is they add value. They add value. They add use value, utility, if you like, to things. They add financial value, and they add symbolic value through branding and narratives around products and services and so on and so forth. Now, there are other competing definitions of design that I'm very, very, very well aware of, but I've yet to see those definitions work their way through into everyday design pedagogy, except in maybe one or two very pronounced and loud institutions. So I can't cover everything that I covered in my paper, so I'm just going to concentrate on one of the things that I hoped to offer some insight into, and that was the consideration of the relationship of design to other key upcycling terms such as waste, quality, value, and so on. And I've been working over the last year or so on a series of kind of mini case studies, which I can only give a brief flavour of here, that I think illustrate different aspects of how we might think about design in relationship to upcycling. First one is shoddy, from where we get the term shoddy goods. Now, shoddy was a very successful 19th century industry which took waste wool, shredded it, processed it, and returned it as a yarn that could be made into new garments. Now, there's no design in here. There's no role for designers unless you want to say, well, somebody designed the process of taking the waste wool and turning it into fresh yarns. There's some design input, I suppose, in the clothing that resulted in shoddy and the new sets of clothing that came from shoddy. And shoddy clothes were known to be less durable than the original clothes, because as you reprocess any of these yarns, they become slightly less durable, they lose certain kinds of integrity and so on in the fibre structure. Shoddy is still produced today, but tends to be used, as you can see on the picture on the right, as packaging material or stuffing material for insulation or for furniture. However, there are modern equivalents of shoddy manufacture using other materials such as polyester, nylon, and so on. And design plays an interesting role there because, again, recycled polyester and nylon don't have the same structural qualities of the original materials, but they can be used for clothing. So what you see in fashion industries is designers working very creatively with these fabrics, maybe turning them rather than the panels of the garments into trim, adding a certain kind of branding to them or other kind of design elements to make the best of the material constraints that are offered by, if you like, remanufactured, reused nylon and polyester. The second example that I think is interesting is the well-known one of fleeces from bottles. So we take bottles, PET, this can be ground up, processed and so on, and can result in yarns, which we can make fleeces out of, basically. This is a well-known, almost very stable recycling, or you might say upcycling industry. Although you have to then ask the question, well, where does the value lie and how do we how do we determine the relative values between plastic bottles and fleeces? Is one more useful than the other? It's not just always about monetary value, it's about kind of the use value of the object in a particular context as well. And context is always very important in these things. Now, there's a high design content here. There's a high design content in the bottles in the first place. They come in various shapes and sizes. There's been quite a lot of innovation in the kind of tops, not just the screw tops you can see there, sports valves and so on and so forth. And of course, in the branding of them and the positioning of them in market segments. And we can say the same about fleeces, that, you know, different companies take different styles, different approaches. They can add value through branding designs, such as the one you see there, which is Patagonia, which you'll pay more money for because it's Patagonia rather than a fleece off the market, even though the raw material is the same. And what strikes me as interesting about this, it's like that old Schumpeter thing about creative destruction, but you have a lot of creative destruction of design in this process. The design that goes into the bottles, the design is destroyed. Other designers then design the fleeces. I think that's quite interesting in terms of the role of design. Design is very pronounced in this process. But actually, this process is under threat. This economy is under threat because we're now on the cusp of being able to break down PET using enzymes to produce virgin PET, which can then again be used for bottles. So it may well be that in the future, the plastic bottle industry is a little bit like the milk bottle industry used to be, where they can be endlessly reused. That raises an interesting question about, well, what do you want? What do you want in terms of upcycling in the future? What's better? Is it better to take plastic bottles and turn them into useful fleeces, garments? Is it better to take plastic bottles and turn them into plastic bottles? Or is it better not to use plastic bottles, disposable plastic bottles in the first place? And depending on the outcome of those kinds of processes, which won't be driven by design, we will see that there will be opportunities for designers to respond to those processes. The third example that I'm quite interested in is a more historical one, the ARP railing. Now, if you live in the UK, you're probably very familiar with the story of how all the railings on the walls were taken down in the Second World War. And the iron was melted down and we don't know what happened to it. Was it dumped? Was it used? Well, we know some of it was used. And some of it was used to make ARP stretchers here. Now, the only design here was the fact that it was a pre-existing design for the stretcher, an emergency stretcher for people to carry victims away from air raids and so on. Very uncomfortable, very functional. But very interesting in terms of the questions about upcycling. Now, was this upcycling? Was taking railings which serve one purpose in one context and turning them into stretchers upcycling? Well, perhaps. But what's interesting about this example is in the post-war period, the railings were then taken and turned back in, the stretchers were then taken and turned back into railings, possibly not from the walls they came from, but they became railings again. And I think this is a really interesting kind of example of is this upcycling? Is this downcycling? Is this side cycling? If we're going to have a kind of directional metaphor for these processes, I'm not sure that up is always the correct one or the most appropriate one, but I like this because this is kind of vernacular. This is somebody took the decision for this reappropriation of the stretcher back into the railing, and I'm not been able to find out too much about that, but it's kind of upcycling without upcyclers in a sense, a bit like we talk about in the design literature of design without designers. And my last example is wonky carrots. For many decades, the supermarkets have put an awful lot of pressure on farmers to produce uniform fruit and vegetables. But then a few years ago, apparently there became a demand for more natural produce. And so supermarkets decided that they were going to sell ranges of wonky carrots, wonky fruit and veg, but I like wonky carrots because I like carrots. Now, what's quite interesting about this is that the supermarkets knew that farmers always produced a certain number of wonky carrots as a byproduct of trying to produce uniform straight carrots. And the wonky carrot, therefore, was taken from the farmers under the supermarket's direction, and the only real design content is that a graphic designer's come along and provided some kind of branding for it. But you can't go too over the top when you're trying to sell naturally wonky carrots. So you don't want anything too ostentatious, but there's very little design here. In fact, unlike other examples of upcycling, there's no reprocessing here. Nothing's added, nothing's taken away, apart from the bag. There's no reworking. It's simply the transposition of one, if you like, commodity across markets and across kind of cultural narratives about products to another one. But what's quite interesting about this one is that the supermarket's demand for wonky carrots has actually destroyed a circular economy, because previously what farmers did was to take the wonky carrots and use them either as fertilizer on their fields or food for their livestock. But now the supermarkets demand those wonky carrots. And so farmers have had to accede to having that circular economy broken up, and have now had to go back to tapping into two linear economies previously they could avoid, which is one for replacement feed and one for replacement fertilizer. So the relationship between design and value and utility in upcycling is something that I'm very, very interested in. And I don't think we've got any uniform answers to that. So in summary, I would say that the more that I look at upcycling case studies, the more I've come to the conclusion that the role of design in upcycling is specific, it's contingent and contextual. It often depends on non-design thinking and priorities. And fourthly, that design is generally reactive in upcycling and is driven by decisions arising from political economy considerations rather than from design considerations. Okay, I'm not quite sure what we do now. Okay, so yeah, that's me done.
Thank you very much. Yes, very thought-provoking examples. And I think with upcycling, it can be particularly useful to look at different examples and pick them apart and try to understand what upcycling is, in fact. I mean, to me, very often, actually, it's downcycling, or it's recycling, or it's reprocessing and remanufacturing. And I find actually really good examples of upcycling where value is gained at each step actually seem quite rare. I mean, think about the example with the railings. To me, they started with some very, very high quality, solid, beautifully designed railings. They were then turned into some quite sort of quickly made, very utilitarian, but maybe not very high quality stretchers. And then it was interesting in the image where the stretchers were then turned back into railings, they were rusting away because they were then quite thin tubular sections, which actually, had been made for temporary use as stretchers and weren't very durable as railings. So it started off with some high quality railings and actually ended up at the end of the process with some low quality railings. So to me, there might have been a little up in the middle where we needed the stretchers briefly, but overall it seems to be a downward trend. And I find a lot of examples, if you really look at them, you find it's a downward trajectory rather than upward one.
Ben, there's a point here that I haven't raised, which has occurred to me throughout all of the presentation so far, is that there's been an overwhelming emphasis on post-consumer waste. And that intrigues me because, some estimates put post-consumer waste as a little as 5% of the waste stream. Most waste is pre-consumer waste. And I mean, a couple of my examples come from pre-consumer waste, and I think they're the first ones that we've considered so far that are not post-consumer waste. So I think that maybe the repurposing of pre-consumer waste isn't included in upcycling. I don't know. Maybe upcycling should be associated more properly with post-consumer waste. But it's kind of struck me so far that there are already huge circular economies in pre-consumer waste and have been for decades. absolutely decades, because manufacturers have recognized the value of pre-consumer waste and have produced new products from it before we become aware of it. So I'm just, yeah, it's not really relevant to my presentation, but I'm very interested in the notion of pre-consumer waste and upcycling.
Yeah, that's interesting, and I think it's invisible to many people, which obviously why people don't talk about it, but also why designers might not be aware of it. So again, it's a question of more collaboration across industries, so people are aware of the
upcycling projects I've done with students have been with pre-consumer waste. So.
Right. Okay. Interesting. There's a comment from Donna Mayone commenting about the bottles to fleece and mentioning unintended consequences. And it's actually a word that's come up in my mind during quite a few of the presentations and examples is unintended consequences. So it's about the fact we'll then get microplastic runoff as you wash the recycled fleece. So actually you've gone from some quite stable plastic bottles through to something that then starts dumping microfibers into the oceans.
Absolutely.
So of course,
so how do you determine value, utility? You know, especially if you're going to take an environmental view of this as well, it becomes very, very complex. I mean, I think some of the upcycling projects that I've seen of if you just take an environmental dimension of much less benign than the thing that they aimed to replace.
Yeah. Again, I think it just highlights the difficulty of really upcycling and actually getting this true increase in value and utility. And then finally, a comment about pre-consumer waste in fashion design, and that's taken into account, eliminating offcuts in garment construction processes. And so I think there are drivers certainly to minimise.
Well, the third stream, which I didn't mention in my presentation, is that I'm married to a fashion designer who works for a very, very big multinational. They make massive profits. They're way ahead of a lot of academics in their thinking around these things. They've already eliminated huge amounts, as the commentators, they've already eliminated huge amounts of pre-consumer waste. They make such big savings, that hundreds of millions of dollars worth of savings through eliminating pre-consumer waste. So they're not always the bad guys. You know, they are doing their bit. Maybe not all of them are doing as big a bit as they could do, but certainly some companies are doing massive amounts in terms of tackling pre-consumer waste.
Yeah, because then there's a comment about that there's an enormous industry around disposing or repurposing pre-consumer waste, which you could say is a good thing, but it depends how well it's being disposed of. So, and the problem is if we don't get to see those waste streams, we don't get to suggest alternatives or to optimize those flows if there's just this enormous industry around disposal. Okay, sorry, I think we should really move on. We could probably talk all day, but we need to move on. We've got 2 more talks before the break. So thank you again, Neil. Now we move on to object-oriented upcycling, an object-based approach to the circular economy. Fernando, Sille, Jeremy, and Ashley. So over to you. Great, that's working.
Yeah. Okay, my name is Fernando Galdon, and together with Sille Bertelsen, Jeremy, Hulse and Ashley Hall, we have presented our paper, Object-Oriented Upcycling, an object-based approach to the circular economy. We are representing Innovation Design Engineering, which is a double master between Imperial College and the Royal College of Art in London. This was the initial brief that we set to students. So it was about designing furniture user interfaces, and then we place in the context of dream and dystopias. The kind of questions that we ask is, how can furniture design evolve while maintaining and supporting our quality of life, together with notion of sustainability, circularity, and respect for the environment in the context of an exponential population increase rate, and how these objects interface and coexist within these tensions. This is more or less how we approach the process. So we work with frameworks because we need some kind of flexibility. So it's kind of a semi-structured questionnaire. So first we define a research territory where the students can project their passions or their intentions, and then we have a back and forth process between concept generation and design development. This is the constructivist space that we have for something to emerge. Then we have the production process and the presentation where we implement an evaluation. In this case, we approach from a object-oriented ontology. So for Harman, the research program of OO is precisely focused to magnify the tensions between the object and its appearance to consciousness of the object and its qualities by invoking a constant formation of hybrid entities in which human fuse with non-humans. We are showcasing 2 projects from our students, from Jeremy Hulse and Sille Bertelsen. So in both cases, they decided to start with the local waste from the RCA and Imperial College campuses as a starting point. In the case of Sille, she came with an object. I say, okay, this is the kind of chair I want to design. From that, what she did was deconstructing that object and say, okay, this is the kind of elements that are going to need in order to make this object real. Then she went into material sourcing. So she moved into all the workshops around the campus, and from the offcuts from workshop waste, she started to put everything together. Then she did some research into how I can put everything together without using glue. So she looked into traditional joining techniques in order to manufacture that. Here we can see how this joinery start to work. So it's mainly traditional joinery techniques. So it's very relevant the past to bring something into the future. Couple of notes, for example, natural dye, the fabric from canteen waste. And in this case, it was using offcuts from onions in order to give color to the fabric. And in order to put the upholstery together, see and thread existing fabric in order to thread the new upholstery. In the second case, Jeremy mapped or researched the area, and he realized that there was a lot of waste with chopsticks. And he said, okay, this is the object that I want to focus on. So then he designed 2 boxes to collect chopsticks, and he placed in different places in the campus. And then he started to collect an astronomical amount of chopsticks. So once the object was defined, say, okay, I have this extraordinary amount of chopsticks, what can I do with them? So he started to experiment with the structural forms. Okay, how can I put these things together? So this is kind of the early forms where you see kind of a column type and then using bridges in order to foster them without using glue. But then he found out a traditional stick technique, and that allowed him to bend and to play with different kind of configurations. Then he ran kind of a stress analysis to see how much I can push this material and what kind of forms I can get out of them. This is one of the early prototypes, and we were shocked of how strong that configuration was. So okay, let's put this idea forward. So he started to play with that, and he created a structure, and then he built a range of platforms where he can place all the chopsticks and create like a one-to-one model. This is him like putting everything together. In terms of outputs, these are the 2 final outputs. What you can see is a high quality structural and aesthetic outputs aim to enhance the value of waste material and exemplify a new approach to waste management in the context of furniture related products. What is fascinating for me was that both of them started in the same point, and both of them ended in really high quality object by the process by which they achieved that was totally different. So in the case of Sille, she started by identifying an object of inquiry, then she identified the key components, then she mapped materials and see what is available, which is wasted, and then she reconstructed the original object using this kind of offcuts. So we see this as a top-down approach, and we are defining or characterizing that as the reconstruction method or process. In case of Jeremy, he started by mapping waste materials, then he identified the object of inquiry, Then he started to define the qualities, how much I can push and do with it. And then he articulated a modularity in this case to define like a new object. What is interesting about this process is that you can put them apart in a sense. I mean, in Sille's case, all the chair is holding using 9 screws, so you can take completely apart. So the question is whether we can build a circularity out of that. Because the current models that we see, and probably all of you are familiar with the Nike, is that they take a waste material and they create a new product out of that. So it's kind of a linear process. The question is whether we can build a circularity. So we can take off cuts and then we can build a product and then we can take it apart and then we can build something else. But this is a question that remains open. And for us, it will be really interesting to see how we can systematize this process. So out of this, how we can create an hybridity out of these processes. So if we go to the idea of object-oriented ontology and we start to fusion with object-oriented upcycling, then the OU research program focuses on magnifying the tension between the object and the appearance to consciousness of the object and its qualities. And that prospective circularity would be articulated by invoking the constant formation of hybrid entities in which humans fuse with non-humans. So this is our presentation.
Thank you very much. Fantastic. 2 really nice examples, which got me thinking about a couple of things. One is about going back to traditional techniques. I think this often works well with upcycling, where traditionally people had less access to materials, less access to different processing technologies and so on. And so the traditional methods allowing you to, for example, as we saw there, join wood just using other pieces of wood, with pegs in the connections, gives these techniques that are actually very, very well suited to upcycling. But then also the importance of the connections, and how we join these materials. So we saw Jeremy exploring different options, and early on thinking about using other materials with the zip ties and the metal straps and things, which always seems a shame, if we're upcycling, we're reusing materials, then we have to start introducing other materials. And then it's really nice if you manage to upcycle just using the objects that you found and not need those additional connections, and the same for the pegs and so on. So yeah, very, very nice case studies. Are there any questions, either hands up or in the chat? No, I think no other questions there. So let's move on, which will almost catch up. Just some positive comments from the audience about fantastic presentation, and thanks for showing those 2 projects so clearly. And if we move on to the last presentation, that will get us almost back onto time. So the last one, we've got Ishan Khosla.
That's right. Hi.
Are you ready to? You okay to share your screen?
Yes, I'm just doing that. I'm having some network problems. I hope it goes well.
Okay.
Just let me know when you guys can see my screen.
Yeah, that's working.
Okay.
I mean, if your network does start struggling, one thing is to turn off your video. We should still be able to see your screen, but without the video, it might sound better.
I just might do that. Just bear with me for a second.
Yeah.
Actually, okay. So do you see the entire screen, or do you see?
No, we can see the next slide and current slide and things.
I'm sorry. Okay. Okay, I'll just do it this way. All right.
Yeah, that's perfect. Thanks.
Okay, great. Okay, so good afternoon, everyone. Thank you for having me here. Excited to be part of this symposium. My name is Ishan Khosla, and I'm going to be talking about Afterlife, which is looking at lessons on product longevity from the informal economy in India. And I hope you're not seeing my screen. I'm just trying to hide my view. Yeah. Okay, so I'm a designer. So my background is actually, I was in the US for about 12 years and studied there in the School of Visual Arts in New York. Moved to India about, in fact, 12 years ago, and got interested in how people behave very differently here than in the West on the streets, and what makes people do things in certain ways. And in fact, when I first moved to India, one of the things I encountered, so I'm not trained in product design, I'm actually a graphic designer, but one of the things that I happened to do is that I picked up an old New York roadblock that I brought back. It was actually discarded and broken. And there's this process called jugaad, which means improvisation in India. And actually, I just happened to have these 3 different pieces. And I came to India, and then I was trying to figure out what can I do with these 3 pieces of the roadblock. This is not the original. This is a prototype that was made later. But I do also have the original. And I basically stumbled upon this idea of just making it into some sort of a table and a bench and a chair using hinges. And so this was kind of my introduction to upcycling, if you will. And beyond that, I got interested in the informal economy. And I feel that India is a very interesting playground of resourcefulness, where risk-taking and experimentation is part of everyday life here. In the informal setting, every person, every vendor, from the barber to the cloth merchant, people on the street, they make their own furniture from scavenged materials that they find nearby. So I found that very interesting, and I've been documenting this for a few years. The fact that vendors are also involved in making of the furniture perhaps creates an emotional link to the object, because many times I ask them to, if I could buy this or take the piece and keep it at my studio. And there's a lot of resistance. So, they really value these objects. In fact, they lock them. Some of them even keep them locked up at night, even though they're in pretty shabby state, as you can see. I wanted to understand, what are some of the lessons that this kind of behavior can provide design that you see on the streets of India? And, can design really break free from the trend-driven market forces, we basically live in a world where everything is about desire and the new and the next version, right? So how can we break free from that cycle? And can, instead design create emotional linkages between consumers and objects, so that the consumer may want to actually care for or repair or, keep that object a little longer than just discard it. I know that in the informal setting, it's different because it's also related to economics, but can this happen on a more larger scale? And some of these questions are very systemic in nature and perhaps beyond the scope of this paper, but they do reach to the heart of, what the capitalist economy we live in, some of the outcomes of that, I guess. And so in order to, address some of these ideas, I conducted a class last year at CEPT University in Ahmedabad called En Plein Air, looking at rethinking, making, and designing in the informal economy. And, basically, we were looking at what makes an object to be perceived as not valuable after a while, right? Why do people not value what they buy after a while? Is it because it becomes old or blemished? And how do you actually bring in value through renewal? So can you actually take an object and by creating an intervention or promoting an intervention in the user or urging the user to actually do something with it, create some sort of renewal and new interest in that object itself. So initially, I asked the students to work in conditions that mimic the informal economy. So in fact, they were not told what they were going to be making. They were just sent out onto the streets to scavenge materials and find things, all over the city in Ahmedabad. So they actually also had to do a mapping of all the materials they found and a knolling exercise. And after all this was done, they were told that they had to make a chair. A lot of them struggled because they didn't know that they had to make a chair beforehand. So it was also a way to challenge design. That can you make something functional out of something obviously waste materials without knowing what you may make. So it was challenging this whole process of how we even design and manufacture, where we always try to find something virgin and new and then form it rather than working the other way around. I'm not going to, like in this presentation, because of the shortage of time, I unfortunately won't be able to delve deeply into these projects, although they're very interesting. Each student and each group looked at it in a very different way, but I just want to kind of make a connection to this idea of behavior and the idea of how to create emotional linkages with objects that you own. The other thing was that, then they were asked to do an intervention where they were actually asked to observe street vendors and their furniture and how they use that furniture. Did they use it in unusual ways or multiple? Did they use it in a way that it was not meant to be used as, etc. And so they had to do a photographic study and pair themselves with these users. And in fact, then they were asked, they kind of became the client of the user. And, for instance, this person here, who was a fruit vendor, basically he uses this table, which he also uses as a stool, but he could not reach up to where he needed to reach. So he actually requested if there can be an intervention made where he could actually, almost use it as a step ladder. So this was one of the types of interventions. So there were a large number of students, and probably we did about 8 or 9 different interventions. I'm not going to be able to show all of them, but this is just to show you the kind of intervention that was made by the students with the vendors, taking them into confidence. I think one of the things that was important was not to totally change the form of the original object, keep something pure, because they had an emotional attachment to that object. So, I mean, here, this is before social distancing. You can see 2 guys sitting next to each other. This is at a tea vendor shop. And he doesn't have a table, but he can offer his customers a place to sit for a few minutes and have a sip of tea. But he didn't have enough chairs as well. And so this was an idea that one of the students came up with discussing it with the vendor to kind of come up with this sort of a chair. And basically there were various other studies that were done on how people, behave with their furniture in terms of posture and gestures and, basically what makes them not throw that object even if it breaks down. And for instance, one of the interesting projects that one of the students did, Bhavya, was to actually, so he took this vendor's chair, and which is made of plastic and has a cushion on top, but he reinforced it with bamboo, but he also designed it in such a way that it could also, the bamboo parts can be replaced, because this vendor also used to take this chair with him every night on his scooter. So he would put the chair on top of his scooter or bike and drive away. Apparently the chairs are very valuable to them because they felt that people keep stealing them. And so the point here is that how do you make something replaceable, easy to replace for the user, or customizable, like where they can change something and not change the whole thing with it, not throw the baby with the bathwater, so to speak. And I think some of the key, just to conclude, because short of time, some of the key observations were that I think, what was interesting is that none of the material interventions made by the vendors were done for physical beautification. It was really done to reinforce it, repair it, or to change the way they could use that object. I think my slideshow is, sorry, it's just got jammed up. Can you guys hear me?
Yep, that's fine.
Okay, so I'm just going to conclude just my presentation, somehow not moving forward. Okay, hold on. Yes, apologies. So basically, we noticed that they use objects or transformed objects in different ways, rather than kind of making it, like painting it or beautifying it, and that was interesting for us to see. And sometimes they would even add appendages or some sort of extraneous piece which they would scavenge to change, again, the function, but not for the sake of aesthetics or ergonomics. And I think what was interesting is that ironically, the wear and tear marks of the objects were not seen as blemishes, but it was really seen as a aging process, and maybe a connection became stronger with the owner and their object. It's almost like a human connection, if you will. And we found that very interesting to see, and which is fairly universal, these sort of connections. So, while the informal setting throws up these striking examples of how emotional bonds between an object and a user makes them more reluctant to discard that object. How does this work in a more capitalist mass production kind of system? That's going to be another challenge. And I think one of the learnings I can just reinforce here is something like this, where an object allows itself to be basically replaced in parts or customized. So where the designer involves the user as a participant in the process rather than just a spectator. And I think the old model, of course, was that you had the maker and then the designer and then the consumer, but now, maybe the maker, the designer, and the consumer are one, or they're getting closer to each other. Perhaps maybe the maker and designer are not always the same, but they are getting closer. And so this is the kind of model we need to move towards, perhaps. One of the things I also wanted to add was this importance of storytelling in terms of provenance or historicity that can be embedded into objects, which designers are really good at doing. So this is an object from a colleague of mine, Trent Jensen from Australia. I won't describe it, but basically it's a tea set of the Bridgens family, mixture of Aboriginal and white Australians. And he's actually personalized and characterized each object as per the original personality of the people, using various materials, etc. So it creates a sort of another texture, another layer, which makes it interesting. It's not just a cup that once breaks, you discard. You can actually repair it. And that brings me to things like kintsugi and darning. So in India, there's this tradition called rafu or darning, which is not very different from the Japanese kintsugi, where actually the idea of age is celebrated in a way, right? So it's about preserving or actually accentuating beauty of aging rather than hiding it. Yeah, so I think I'll just leave it there. I'll just conclude with this statement that there is a company in Mumbai that is looking into making commercially available furniture through this kind of method of involving the consumer as a maker and designer. Yeah, thank you very much, and I'd be happy to take your questions.
Thank you very much. Fantastic presentation. I think I touched on a lot of very, very important issues about time and about people making their own objects and attachment to objects. And all the way through, I was thinking a lot about time and the importance of time and gradual changes over time in making this attachment. I think there's a problem when we have sort of student projects and we try and do upcycling quickly, and we try and make a finished upcycled piece and pass it on to something, as we lose that element of time and interaction and a sort of iterative process. All the examples you showed from the street vendors and other people, it was clearly a very slow process where those pieces of furniture had been changed and changed again. It had happened over many years, and that builds up the attachment, which I think is quite different to trying to do something quickly or to try and make something that's seen as finished at the point of sale. So I think this whole element of time is important. And just going back to the start of the presentation with the roadblock example, I thought that was very interesting, just because it was such a small intervention. And maybe that's another key to upcycling, is being able to just make a very, very small intervention. You just added 6 hinges or something and completely changed the utility of the object. It's a very, very elegant solution. Are there any questions? There are lots of enthusiastic comments in the chat. So Ishan, you should certainly make sure you have a look at that. Lots of people really like the presentation. but none are specifically questions. So, whoa, lots of chat zooming in. None are specifically questions, and we are running late, so I suspect we should finish this session here. I'd like to say thank you very much again to all of the speakers. I think we've had a fantastically diverse range of presentations.